A special feature we have within our library products is the custom calculator. It's actually a toolbox feature that the library takes advantage of. So with this, we can add one or more multiple calculators to any product or subassembly. And this allows the user to calculate any number of things. The best example of this is probably the drawer front calculator. I'm looking at a starter product right now. We'll look at a drawer bank cabinet in a little bit later. But in this product, we're using the calculator to calculate our bay openings in this horizontal starter. So basically, the way it works is you open up the product, right-click, calculators, and it's going to be right here. You can find it that way. It's also under the menu, calculators, same thing. And from here, by default, it's going to be 3 equal openings, and it responds to the number of bays that you have. So when you have, 2 bays, depending on whatever that's set to, you'll get that many different, calculators or openings. So let's just put in something here. So say we want, 15 inches in the middle, and then equal these guys like that. Let it redraw. So now you've got your 15 inches inside, and then whatever the difference is for the left and right. If you are familiar with this feature from an older version of Microvellum, I'd like to point out that this is now much more dynamic than it was previously. In the past, for example, if you change the width of this starter cabinet, the math would be broken until you ran the calculator again. I have fond memories of constantly being pestered about a pop-up message saying something like, do you want to rerun the calculator before redrawing this product? So for now, that's no longer the case. Now you can just change the cabinet here, and it will maintain that whatever you set previously, 15 inches equal. So we store this information in the spreadsheet, which of the openings is selected to be equal and which ones have that hard lock value. So I went ahead and deleted that cabinet and drew a fresh one. I just want show you an unaltered product right out of the library before we make any changes. Just take a look inside at design data and see what we can see here. Okay. The list of calculators is stored on this column right here, which is column R in the spreadsheet. And you can have more than one calculator, like I said, but most products, they typically just have one calculator, but you can have, as many as you need. And then the index is to the left here, these guys. So this is where we specify which of the prompts are assigned to said calculator. So this kind of works just the same as your tab list and your tab index. If you're familiar with the tab index, how you assign, which prompt you want to go on what tab. Here you assign which calculator, goes to what prompts. And the calculators, just like the tabs, they are assigned a number starting at 0. So you're going to have 0, 1, 2, 1, 2, 3, 4. And each calculator needs to have 4 pieces of information in here, and they're separated by the pipe symbol. The first one is the name of the calculator, and this becomes extra important if your product has more than one calculator. So you want to make sure you have a name of what this calculator is going to do. The second one is the overall distance or space that we're working with. So in this case, it's the opening width. The third parameter is this guy here. It's going to be the gap or the distance we are separating each opening. So in this case, we're looking at the division thickness. It's going to return to 3/4 of an inch or 19 millimeter. And the last value is going to be the number of openings this calculator is going to use. So in this case, we've got the bay quantity, which is returning 3. So that's the value. This is actually an optional parameter, this last one. If the program does not see a fourth parameter here, it will assume the older method of counting the number of calculator index numbers to determine the number of openings. That's kind of how it used to work in older versions. So we would have to put formulas in here that would, return a quote to make it blank, so that it would have to look like that in order to tell the program this is 3 bays. But that's no longer the case now that we have that. In fact, your library may have that as what I'm describing. You may find formulas in here, something to the effect of, looking at the bay quantity, it's a 0, otherwise it's quote. So that'll still work just fine, but this is maybe a little bit easier because there's less formulas. So in this version of the library going forward, an unaltered starter product, you should have all zeros. So 0 is going to mean the first calculator. If there were 2 calculators, then you would maybe have a bunch of 1s. That would mean the second set of things you wanted to calculate, but we don't. So yeah, so with the quantity of 3, it's going to start at the top 1 and only look at the top 3. As soon as you say bay quantity 4, it's going to look at the top 4. So the order of these prompts is very important. In this case, if you were to reverse the order of these, prompts here, it just wouldn't work. You would have to have these in the order that you see here. So let's go ahead and make a change in the prompts and kind of see what happens to this. So we come into the prompts and we make, let's do the opposite here, calculate, okay. You can kind of see there's a preview of what it did there. Hit OK. So now let's go ahead and reopen the spreadsheet and see what's going on here, what happened. So by changing the openings via the calculator, a couple things were edited in here. I see the formulas. Originally there were formulas in all of these bay openings, but they've now been stomped on with what we evaluated it to. So it took the opening amount. So if we look at this, so it took that opening amount, subtracted the amounts that we typed in, and then it subtracted the 3/4 of an inch thickness of the divider 2 times, because there's 3 openings, and then it evenly distributed the remaining distances equally to the openings that we checked that we wanted to be equal. We also see here that prompt that we selected that we wanted it to be equal is now says 0.1. The 0 tells microvillm that this is the first calculator, right? But that 0.1 tells microvillm that this is the prompt to always be calculated as equal. And what this allows us to do is maintain a parametric product. So even after you've calculated something, it'll remain parametric, as I demonstrated earlier. So let's take a look at another example. Here's a drawer bank calculator. So if I look, I can see, I can set this to be maybe 6 equal, calculate, okay. And we got our 6-inch drawer front here. So let's take a look how this looks. So here we have 3 pieces of information. So like I was saying, it's missing that last, quantity, and that's fine. This is just a different way of going about it. But because of that, we need to tell the program how many things to calculate. And so we are calculating 1, 2, 3. So the program knows that there are 3 drawer fronts. Well, it doesn't know that it's a drawer front, but there's 3 items to calculate. And because I said equal equal on the top and bottom drawer front, these were stomped on a value of 12 and a 16th, and then this one was 6. And so everything's working. The only difference you may have noticed is the gap is set to a 0. And you would think, well, that should be 1/8 of an inch, right? That's the gap between the drawer fronts, or whatever the horizontal gap amount is between those drawer fronts. However, one limitation with these calculators is that when the gap amounts need to vary. So for drawer fronts, we have options like a finger pull rail, where the distance between the top and second drawer front might be different than the distance from the second and bottom drawer front. So here's an example where we have a lock pan in between the fronts. So that's going to be a different gap between these drawer fronts versus these drawer fronts. So when we have that kind of a scenario, so to address that, one math trick that we can do is set that to be 0, the gap to be 0, and instead you subtract it out of the second parameter, and the problem is solved. The calculators can also be found inside subassemblies. So opening splitters are a great example of this. So if we just go into that first bay, put in a vertical splitter, okay. So I went ahead and added this opening splitter inside the bay 1, which is a good example of putting a calculator inside of a subassembly. I'm going to use the prompts here I'm going to view the prompts of this splitter. Hit no to see the parent. And here's our 3 openings, the calculator. So I can say maybe a small 6-inch there in the middle, equal, equal, calculate, okay. And okay, let this thing redraw. And there you go. And it should remain parametric even if this overall cabinet height changes. That calculator will update accordingly. Well, if you have any questions about custom calculator feature, feel free to use the comment section below. And thanks for watching.